Hi, and Assalamualaikum. So we will discuss for the partial test 1 for 2019 and 2020. So the first question, they give us an equation of fxyz equals to x squared minus 2x plus y squared minus z. So the first question is to prove that when it passes through the point 103, it will become z equals to x squared minus 2x plus y squared plus 4. So for the solution for the first question, we just substitute the point into the original equation. Then we get the negative 4. Thus, we will combine the original equation and the negative 4. Then we arrange it and make it z to the front. So we can get the equation that we need to prove, which is z equals to x squared minus 2x plus y squared plus 4. So for the second question is to find the domain and range of z. So we know that z, there's no any constraint. So the domain is only xy, where both of them are a real number. Then for the range of z, we change to the vertex form. Then as we can see that when x minus 1 equals to 0 and y equals to 0, z equals to 3. Thus we know that the range is z is a real number where z must be more than or equals to 3. So for the third question, which is C, they ask us to sketch the level curves at z equals to 3, 4, and 5. So we just substitute the z values. Then we can get a circle equation where when it becomes 3, it will be x minus 1 squared plus y squared equals to 0. And when z equals to 4, it will equals to 1. And 5, it was equal to 2. So as you can see that when z is equals to 0, it will be a point at 1 0 1 0. But when z equals to 4, it will be a circle, and for z equals to 5, it also will be a circle. So the third question is, and the fourth question is to sketch the level surface. So we can see that at yz plane, it will become a quadratic curve where z equals to y squared plus 3, while at z plane, it will also become a quadratic curve with the equation of z equals to x minus 1 plus 3. And when xy plane, when z equals to 3, it will become a point, while z more than 3 will become a circle. So the level surface will become like this. Then we will proceed to the second question. So we proceed to the second question. So a cuboid having dimensions 20 cm, 30 cm, and 60 cm is heated so that each side is elongated by 1 over 20 cm. By using partial derivatives, estimate the increase in total surface area of the cuboid. So we know that x is equal to 20, y equals to 30, and z is 60. So to find the surface area is 2 times of each side surface, which is xy plus yz plus zx. And then the question say that the side is elongated by 1 over 20. So it means that dx, dy, and dz is equals to 1 over 20 or 0.05 centimeter. So to find the increase in total surface area of the cuboid, which is ds, we have to use chain rule, where ds over dx, or ds differentiate derivative of x with respect to x, times dx plus derivative of x as with respect to y, times dy, and derivative s with respect to z times dz. So we know that ds over dx is 2 times y plus z. Then we get 1, while ds dy is equal to 160 and ds dz is equal to 100. So we use this formula again and we substitute all the value, and then we get the ds, which is the increase in total surface is 22 centimeter square. Okay, so for the third question, we have to find all relative extrema and set the points. For z equals to 4xy minus y to the power of 4 minus x to the power of 4. So we have to do the second partial test, which we have first we have to find the differentiation of z with respect to x and with respect to y. And then from the equation, we do the simultaneous equation to find the critical points. So we get the x is equal to y to the power of 3 and y equals to 0 and y equals to 1. So we know that critical point is 0, 0 and 1, 1. And then we also have to find the zxx, zyy and zxy, which zxx we got negative 12, x to the power of 2, zyy is negative 12, y squared, and zxy is 4. Then we have to find the d for the two critical points. So for the first one, we find for the 0, 0 point. Then we get the negative 16. So we know that for the 0, 0, it is a saddle point. And then we proceed for the second critical points, which is 1, 1. Then we get d is 128. And we know that zxx is less than 0. So we know that for the 1, 1, it is a local max point. It's not a local min point. This is a typo. So we know that for this equation, we have local max point and also the saddle point. I think that's all for paper 2019 and 2020. Thank you.